November 11th. Once again, astronomers have uncovered terrifying new secrets as 3I, Atlas continues to plunge toward the Sun in a series of relentless collisions. For days, reports of violent interactions between 3I, Atlas and the Sun have spread across the scientific community, yet each encounter brings not destruction, but revelation. With every impact, the object unveils another secret. Laws once thought unshakable begin to tremble, and in the space between fact and possibility, something extraordinary begins to take shape. A question. Has nature just revealed a new law, or are we witnessing the trace of something that was made from the cautious hypotheses of Avi Loeb to NASA's prolonged silence, from the delayed release of images by the Mars Reconnaissance Orbiter to the calls for transparency from the US Congress? The story of 3I Atlas has long surpassed the boundaries of physics. It has become a mirror reflecting the human mind, how we confront mystery, cling to knowledge and tremble before the unknown. And so right now we turn to the latest findings and official reports to explore what astronomers have discovered in these recent days as 3I the Atlas, the interstellar wanderer, continues its dramatic dance with the Sun. At first, 3I Atlas looked ordinary, a dim interstellar wanderer following its path around the Sun. Then almost overnight it changed. 3 days ago as it passed, perihelion telescopes recorded a transformation no one expected. Its brightness increased 5-fold, yet its structure refused to behave. Instead of a single tail streaming away from the Sun, the object released multiple jets in different directions, a tangled geometry of light and motion. And the most recent research shows that one of those jets, the strangest of all, is headed straight for the Sun. No comet should do that. In classical physics, solar radiation pushes dust and gas outward, forming tails that always point away from the star. To resist that force is like watching a river flow uphill. Yet here it was a plume of gas defying sunlight itself. At first, the discovery was dismissed as error, an angle misread an illusion of scattering. But as days passed, the anomaly persisted. Observatories from Chile to Hawaii confirmed the same behaviour. The jets were stable, not chaotic. They formed a pattern that repeated measured, deliberate, almost mechanical. Spectroscopic readings deepened the puzzle. The outflow velocity of the gas was only about 150 meters per second, too weak to resist solar wind pressure. The jets should have bent, dispersed, dissolved. Instead, they held their shape like invisible columns of energy anchored to the nucleus. Every physical model failed. If heat from the Sun caused this, the effect should be random bursts of sublimation, sudden eruptions, short-lived flares. But Atlas showed continuity. The jets pulsed in cycles aligned with the object's slow 9-hour rotation, as if responding to an internal command. To imagine it is to picture something breathing in deep space, a dark stone exhaling threads of vapor, each in rhythm with its spin. It was mesmerizing and deeply confusing. Theories multiplied. Some said the jets came from venting stratification layers of gas trapped beneath the crust, released through different cracks as the surface fractured. But this couldn't explain the stability. Others blamed rotational bias. Perhaps the comet spun fast enough to expose multiple hot zones, yet its measured rotation was too gentle. The physics didn't add up. What was left was speculation, cautious but unavoidable. Maybe the venting wasn't random at all. Maybe it was directional, guided through narrow internal channels like nozzles focusing the gas into precise jets. If so, 3I, Atlas, was doing something no natural object had ever done, adjusting its own motion. Could an ancient fragment of rock and ice possess a self-regulating mechanism, something that mimicked propulsion? It sounded impossible, yet it fit the delta better than anything else. Computer simulations at the European Southern Observatory compared two models, random outgassing versus guided flow. The first collapsed into noise within hours. The second, the channeled emission model, reproduced the exact jet geometry observed. The conclusion, carefully worded, read anomalous collimation, consistent with localized venting or structured pathways. No one claimed design, but no one could ignore the symmetry either. Somewhere between coincidence and intention, the truth waited. If the jets were natural, they revealed a new kind of physics, a way for volatile materials to self-organize and regulate heat release. If they weren't, then we were witnessing something far rarer, an engineered system that had survived for billions of years, now awakening near our Sun. The change from silence to motion, from dormant rock to active structure, was so abrupt, it felt like a switch had been thrown. From that moment, our Atlas was no longer just a comet. It was an experiment, a cosmic riddle about how matter behaves when the familiar rules begin to bend. Scientists spoke softly when describing it, almost with reverence. It's as if the object remembered how to move, one wrote in his field notes. Maybe it did not remember. Maybe it simply responded. To heat, to light, to a condition written into its structure long before the solar system even formed. Whatever the reason, its sudden change marked the beginning of a larger mystery. A reminder that even in the most predictable of systems, the universe still keeps a few surprises folded in its silence, waiting perhaps for the right angle of sunlight to reveal them. For weeks after perihelion 3, our Atlas drifted in silence. No visible jets, no optical flare, just the faint echo of sunlight glancing off its metallic surface. Instruments around the world continued to listen and heard nothing. Then on October 24th, the silence broke. From the high desert of South Africa, the Meerkat radio telescope caught something unexpected, a narrow clean signal at 665 GHz, followed by another at 1.667. The twin peaks of hydroxyl absorption, the molecular fingerprint of water vapor touched by sunlight. It was the first whisper the object had ever made. Hydroxyl lines are ordinary in cometary science, a sign that ice has begun to vaporize. But what unsettled astronomers was when this happened. The object had already passed perihelion. By that point, the heat should have peaked and begun to fade. Yet instead of cooling, 3i, Atlas spoke. The question was immediate and precise. Why now? If the object's activity followed thermal logic, its outgassing should have been strongest days earlier, when sunlight was at its most intense. But no signal was detected then. The first activation came only after Atlas turned away from the sun, as if some internal switch had waited for the right alignment, then opened. At first, scientists assumed coincidence. Maybe a region of volatile ice deep inside finally fractured, releasing a small burst of gas. But the spectral lines told another story. They were too narrow, too clean. A natural venting event would scatter frequencies across a wide range, turbulent, noisy. This, however, was steady, controlled, almost surgical. Professor Avi Loeb called it methodical seepage gas escaping as if through a valve rather than an explosion. It was a poetic phrase, but also an alarming one. For decades, the idea of a comet regulating its own emissions had belonged to science fiction. But here was an observation that behaved precisely like regulation. Not chaos balance, not eruption control. Could this be a purely physical phenomenon? A group from the Max Planck Institute for Radio Astronomy proposed the insulated shell hypothesis. They imagined the object coated in a dense carbon-nickel crust, acting as a thermal barrier. Heat from the sun couldn't reach the interior immediately. It pooled beneath the surface for days until pressure built high enough to crack a vent open. The result would be a single delayed pulse of outgassing, perfectly matching the timing of the radio detection. It was a clean theory, but it raised one more question. Why was the emission so stable, so calm? If a crust ruptured under pressure, the event should be violent, a burst that fades within minutes. Instead, the hydroxyl lines persisted for 36 hours, unwavering, as though the vent stayed open just enough to release the built-up energy without losing structure. It was the kind of balance a system achieves only when it knows how much to release. Some called this the self-regulation scenario, the idea that the object's layered composition allowed it to adjust outflow, naturally maintaining equilibrium, like a biological process, a thermal heartbeat carved in ice and stone. Others leaned further toward speculation. If the pattern was too precise to be random, perhaps it was something else a triggered response. Maybe the sun's radiation didn't just heat the surface. Maybe it acted as a signal. Imagine an object drifting for billions of years inert until a certain combination of radiation, the right wavelength, the right intensity reaches its surface. Inside, something resonates, a chemical lattice, a conductive vein of nickel and ancient circuit. The result is a pulse, a release, a reaction that looks like outgassing but feels like awakening. Was that impossible, perhaps? But the mathematics of coincidence were growing thin. In early November, cross-observations from ALMA confirmed the same frequency, the same pattern fading gently after 2 days. No other emissions followed. One pulse, one breath, then nothing. The data was sent to NASA and catalogued with restraint. Transient hydroxyl absorption event post-perihelion. Duration 36+. 3 hours. No recurrence observed. That was all the official record would say. But among the scientists who had seen the live feed, something lingered, a feeling that the silence after the signal meant more than the signal itself. If it was a natural event, it was extraordinarily disciplined. If it was something else, it was extraordinarily discreet. Either way, the moment marked a boundary, a point where physics and wonder blurred into the same line on a graph. What turned 3I, Atlas from silent rock to speaking comet? A fracture, a resonance, a memory. No one could answer. The object continued outward, shrinking into the distance, the echo of its brief whisper fading beneath cosmic background noise. And yet on the record, those twin lines remain thin, perfect, immutable. They remind us of a simple truth that humbles every scientist. Even silence when it ends carries meaning. By early November, the calculations no longer matched the sky. The predicted orbit of 3I Atlas, drawn from weeks of optical tracking, began to slip. At first, the offset was tiny, a fraction of an arcsecond, then 4. Enough to break certainty. The object was moving away from gravity itself. Every known comet obeys one master, the sun. Its path can bend, its spin can change, but all motion follows the pull of mass and light. Yet Atlas drifted with a smooth, steady bias, as though an invisible hand were adjusting its course. No collisions, no solar storms, no measurable outgassing could explain it. When the ALMA and Pan-STARRS datasets were combined, the deviation grew undeniable. Mathematically, the force required was minus about 2 × 10⁷, ms2, but consistent. Sustained over millions of kilometers, that whisper of thrust was enough to reshape its trajectory. The term entered every report: non-gravitational acceleration. In theory, such drift can arise when sunlight heats one side of a comet more than the other, causing gas jets to push it unevenly. But Atlas had already defied that rule. Its jets were faint, symmetrical, and fading. If the thrust came from sublimation, the direction should oscillate with rotation. Instead, the acceleration vector stayed constant, aligned almost perfectly with its orbital plane. It was as if the object knew where it wanted to go. Scientists resisted that thought. They searched for hidden variables, thermal lag, mass, misestimation errors in star catalogues. But each correction only tightened the curve. The anomaly remained. A non-gravitational cause meant one of two things. Either the object was producing force from within some natural but unknown venting system, or its motion was being influenced by something beyond ordinary mechanics. The first possibility led to models of subsurface propulsion, a network of sealed chambers beneath the crust where trapped volatiles built pressure, escaping through microscopic vents invisible to telescopes. Each release would be too gentle to form a coma, yet together they could generate a steady push. The physics worked, barely. The precision, however, bordered on artistry. If random cracks were responsible, the thrust should fluctuate. It didn't. For 9 continuous days, velocity increased in a linear line, no spikes, no tremor, no noise. It was motion with intent, or at least with discipline. That word unsettled the community. Discipline implies control. Control implies design. Some whispered the comparison everyone avoided: Oumuamua. In 2017, the first interstellar visitor had shown the same gentle acceleration unexplained by outgassing. At the time, scientists called it coincidence. Now coincidence was repeating itself. Could both objects share a hidden architecture, a structure that reacts to sunlight not as heat, but as stimulus? Could thin metallic layers beneath the surface absorb radiation and release it as directed motion, a kind of photon-regulated drive? If so, it might represent a natural phenomenon never seen before, or a technology so old it has merged with nature. The idea split the field. Half demanded new physics, half demanded humility. But all agreed on one fact: the sun's gravity was not enough to describe what they saw. In Cambridge, Avi Loeb offered a calm summary. The acceleration is small, constant, and unexplained. Whether it is natural or artificial, it teaches us the same lesson: that we still do not understand how some matter moves between stars. Outside the equations, a subtler meaning took shape. Maybe this wasn't propulsion in the human sense. Maybe it was response, a material memory reacting to light after billions of years of exposure, a fossil of motion preserved across time. Imagine an object forged in another system, its minerals aligned in a magnetic field long vanished. Now, under our sun, those same atoms awaken, repelling or absorbing radiation, unevenly creating a drift that mimics intention. The cosmos itself becomes the engine. To an observer, the result is indistinguishable from choice. A rock moves where it shouldn't and we assign it will. But perhaps it is simply obeying laws we have yet to write. By mid-November, the deviation stabilized freezing Atlas into a slightly altered path that would carry it past Mars and back toward the outer dark. The acceleration ceased as suddenly as it began, like a breath released. No one could say whether the effect was over or merely paused. If the mechanism was internal, it might reignite when sunlight struck a new angle months later. If it was something else, something guided, then perhaps the course correction was complete. The final data release read with bureaucratic restraint: observed deviation consistent with sustained non-gravitational acceleration. Mechanism undetermined. Yet behind that sentence was wonder. A silent traveller had shrugged off gravity's chain and rewritten its own orbit. It reminded every scientist watching that even the most elegant equations are still only guesses. In a universe measured by attraction and pull, 3 Atlas moved as if remembering freedom, a fragment of some forgotten order gliding through sunlight with the quiet confidence of something that refuses to fall. When 3 Atlas reached the far side of the sun, telescopes expected to see it fade, its heat dispersing its brightness, falling into ordinary silence. Instead, what appeared was something no cometary model could easily contain: a labyrinth of jets moving not as chaos but as geometry. From the Very Large Telescope in Chile, high-resolution imaging revealed at least 5 active outflows, each pointing in a different direction. One streamed along the orbital path, another angled sharply north, and one against all expectation pointed directly toward the sun. That single jet rewrote the rules. Cometary physics dictates that solar radiation pressure pushes all material away from the sun. It is the reason every comet grows a luminous tail pointing outward. Yet here was Atlas releasing matter in the opposite direction, matter that seemed to resist that radiation rather than flee from it. The data was clean. Spectral maps confirmed a persistent sunward jet steady over several days, its brightness oscillating with the object's slow rotation. It wasn't an illusion, nor an observational artifact. Something in the comet's structure was pushing back. Scientists searched for a natural explanation. One idea suggested day-night asymmetry. Perhaps the jet came from the shaded side where trapped gas escaped through deep fissures and erupted along a path that happened to aim toward the sun. But that still failed to explain the stability. The jet held its alignment for nearly a week, far too long for random venting. Another theory proposed electrostatic repulsion. A solar wind charged the comet's surface. Particles might have been ejected along magnetic field lines that curved back toward the star. A neat concept, yet the required charge density was astronomically high, far beyond anything measured. That left the uncomfortable possibility that the direction was intentional, or at least regulated. If internal channels directed the gas flow through hardened conduits beneath the crust, the result could be a collimated stream capable of overcoming weak solar pressure. Such systems exist naturally on smaller scales in cryovolcanism, where heat and pressure focus into narrow vents producing symmetrical plumes. But Atlas's pattern was too perfect, too rhythmic, almost engineered by its own mineral logic. At the same time, another mystery emerged. Observers noticed a dramatic colour shift. Before perihelion, Atlas glowed a dull reddish hue typical of dust-rich comets. Afterward, its tone changed to a deep metallic blue, a transition recorded across multiple instruments. The shift was not gradual, it happened within days. In astronomy, colour reveals chemistry. Red means dust and organic carbon. Blue means reflected light from smaller particles or emission from excited gas. But the sudden dominance of blue defied both trends. One possibility, Rayleigh's scattering light scattering through ultra-fine particles smaller than a micron producing blue wavelengths. That would imply the object was shedding dust grains far smaller than expected, perhaps the residue of a vaporized crust. Another molecular emission, cyanogen CN and diatomic carbon C2 can glow blue-green when sunlight excites them. Yet their spectral fingerprints were weak, almost absent. So what caused the shift? A joint team from NASA's Infrared Telescope facility and ESA's Rosetta Archive group compared the reflectance data with known cometary spectra. They found something extraordinary. The pattern matched not carbon dust, but nickel-rich silicates minerals that reflect blue light under intense solar heating. Nickel. Again. It was the same element already noted in earlier analyses of the object's unusual density and spectral absorption lines. If true, the blue glow might not be gas at all, but metallic reflection. the exposed skin of a nickel-bearing surface reacting to solar radiation. That idea changed everything. It meant that beneath its dusty outer shell, Thrucius Atlas could have a core made of heavy elements rarely seen in comets, materials more typical of planetary interiors or manufactured alloys. The speculation spread quickly, then quietly. Was it possible that this interstellar traveller wasn't a chunk of primitive ice, but a fragment of something far older forged in the heart of a destroyed world, or built for purposes long forgotten? The idea was uncomfortable even to those who entertained it. No one wanted to say artificial, but everyone felt it hovering behind the data, a presence as persistent as the sunward jet itself. For now, the working consensus was restrained. Observed colour change consistent with thermal alteration or exposure of reflective subsurface material. A neutral line in a paper that concealed deep unease. When the light curve models were overlaid, a rhythm appeared, brightness rising and falling, with rotation synchronized with the shifting hues. Every turn of Atlas revealed another facet, another glint of metallic blue. To the eye it was beautiful, to physics it was unsettling. How could something so small and ancient carry such order? How could a body of dust and ice shine like polished metal under the sun? Maybe, as one astronomer wrote in his notes, it's not resisting the sun, it's remembering it. Perhaps that was true. Perhaps the strange sunward jet and the sudden blue light were not defiance but memory, the echo of an origin in a place where the laws of heat and pressure once shaped it differently. Or perhaps we were simply witnessing how the universe expresses precision without purpose. In either case, the sight of that cold blue traveller reminded us that even the simplest laws of light can still surprise us, that colour like gravity sometimes bends toward mystery. In science, silence is supposed to mean certainty, data under review analysis, in progress conclusions forming carefully. But in the case of 3I, Atlas, the silence began to sound like avoidance. Weeks after the object's encounter with the Sun, researchers expected a full data release. Instead, what arrived were fragments, summaries, partial tables, missing images. The official explanations were ordinary calibration delays, cross-checking, data compression, and yet behind closed conferences whispers began. What exactly are they not showing us? The first to speak publicly was Dr. Michio Kaku. In an interview, he accused NASA of unnecessary secrecy, saying, "If this object is just a comet, why hide the images if it isn't? Why pretend everything is normal?" It was a sharp question wrapped in calm, and it struck a nerve. For decades, the world's space agencies have shared comet data freely. From Hale-Bopp to 67P Churyumov-Gerasimenko, every image, every spectrum, every anomaly had been made public within days. But with Atlas high-resolution images from the Mars Reconnaissance Orbiter MRO captured on October 2nd and 3rd were delayed for more than 3 weeks. When they finally appeared, they were cropped, compressed, and quietly filed without announcement. What they showed, or what they didn't, became the centre of debate. Insiders described the raw images as visually unusual. Unconfirmed leaks mentioned sharp surface contrasts, almost architectural shadows inconsistent with the smooth contours of known comets. Others dismissed it as overexposure, a trick of light artifacts of digital correction. But the timing was strange. In the same week the data was withheld, Congresswoman Anna Paulina Luna sent a formal request to NASA demanding the release of all Mars-based imagery related to Atlas. Her statement cited possible irregularities in the data pipeline and unexplained delays inconsistent with standard planetary imaging schedules. A few days later, a second request followed, this time asking for telemetry from Perseverance, the rover on Mars, which had reported unusual activity in the upper atmosphere on October 5th. Officially, the rover was never looking at Atlas. Unofficially, it was in the right position to detect its light. What was this unusual activity? The public reports remain blank. To be clear, most scientists don't believe in conspiracies. Data takes time. Instruments fail. But the pattern was undeniable. Too many delays, too many missing frames, too much caution for something labelled a standard interstellar comet. In internal memos later leaked to journalists, one line stood out: certain imagery may require contextual analysis prior to release. Contextual analysis, a phrase that said everything and nothing. What kind of context does an image of a rock need? Some speculated that the delay came from data saturation, that the raw files contained optical flares or pixel noise that looked like artificial geometry. Others whispered of signal contamination, Perhaps the radio instruments picked up reflections or interference from the object itself. Whatever the reason, the effect was the same. The public narrative slowed, the mystery grew, and 3 sus Atlas drifted deeper into secrecy. Even now, fragments of those missing images surface, occasionally blurry reproductions adjusted for contrast shared by anonymous technicians. In one, the object appears almost facetted, as if its surface were divided by panels of different reflectivity. In another, the sunward jet glows with a uniform blue hue, not the irregular pattern of dust or gas. Each pixel becomes an argument. NASA has neither confirmed nor denied their authenticity. Instead, their statements remain procedural. Images are being processed for scientific accuracy and will be released once validated. Weeks turned to months. The validation never came. Transparency, once a cornerstone of space science, began to feel conditional. Some defended the caution. The data must be right before it's public, they said. Others countered that the delay itself distorts truth, creating suspicion where none may exist. Between those two positions lies the uncomfortable core of modern science, the balance between certainty and openness. Perhaps what's being hidden isn't revelation but confusion. Perhaps even the experts don't yet understand what they're seeing. In one closed symposium, a senior astronomer reportedly said, "If the images show what I think they do, we will need a new vocabulary." That sentence never appeared in the official transcript. Outside the scientific world, the story evolved on its own: documentaries, interviews, conspiracy threads. Some claimed Atlas was an ancient probe. Others said it was a natural object misread by overzealous minds. In truth, the only mystery greater than the object itself was how little anyone seemed willing to say about it. And so between speculation and silence, 3 Atlas became something rare, not just a question of physics, but a question of trust. When data disappears, meaning multiplies. When silence replaces explanation, imagination fills the vacuum. And somewhere in that gap between what we know and what we're allowed to see, wonder begins to sound like warning. Maybe nothing was hidden at all. Maybe the real secret is that we still don't know what to believe. By the time the debate over missing data began to fade, another revelation was quietly emerging, one buried not in secrecy, but in the numbers themselves. Spectral analysis of 3I, Atlas, suggested something extraordinary. This traveller from the void was older than the solar system. The isotopic ratios of oxygen and carbon were incompatible with any known bodies born under our sun. Their chemical fingerprints, measured by infrared spectrometry and cross-verified by ALMA, pointed to formation in a star system at least 7 billion years old. Older than Earth, older than the planets that now observed it. That single number changed everything. If true, it meant Atlas was not merely a visitor, but a relic, a survivor of a long-dead star carrying within its atoms a record of conditions that predate our cosmic neighbourhood. Its structure, its orbit, even its stubborn resilience might all trace back to that forgotten place. But where could it have come from? Models of galactic motion suggest that over billions of years, stellar systems drift, collide, and dissolve into one another like waves crossing an ocean. A fragment ejected from one such system could wander interstellar space indefinitely frozen, bombarded by cosmic rays, altered molecule by time itself. Yet 3I, Atlas, did not look eroded or ancient. It looked preserved, as though it had been shielded, protected, or maintained. When the surface composition was reconstructed from the spectra, another surprise surfaced: a nickel-to-iron ratio several times higher than that of typical comets. Nickel, a metal that resists corrosion, that forms alloys used in spacecraft and turbines, not the brittle ices and silicates that define natural comets. Some scientists immediately suggested a plausible origin. Perhaps Atlas was a fragment of a planet's metallic core torn apart when its parent world collided with another during the violent youth of its star. If so, its composition would explain its resilience, a shard of a world's heart refined by pressure and time. But even that scenario failed to account for the balance of elements. The object's reflectivity, magnetic response, and heat retention suggested an engineered alloy, a mixture not typically found in planetary formation models. Of course, no one dared publish that conclusion outright. In scientific language, they called it non-standard metallic enrichment. In private, they called it impossible. If this object had indeed travelled for 7 billion years, enduring collisions, cosmic radiation, and temperatures near absolute zero, then what preserved its internal symmetry? Why did its surface reflect light, like polished mineral, not like fractured stone? A few proposed that Atlas could be the remnant of a technological civilization, not an intact machine but debris. A piece of something larger, once functional, now eroded into myth. A drift of interstellar wreckage mistaken for ice and dust. That idea, while electrifying, faced the same problem as all bold ideas proof. The data offered none. Only suggestion pattern and unease. Still, the coincidence was haunting. The unusual composition matched no known class of natural objects. The metallic core model explained much, but not everything. Its reflective spectrum mirrored nickel-iron composites similar to those used in engineered materials on Earth. Its thermal stability exceeded the limits of porous rock, and its magnetic response behaved not like a random mass, but like an organized field. Could these be natural consequences of an alien environment or remnants of design so ancient it now behaved like geology? To answer that, we would need to know the system it came from, but the galaxy had long erased that trail. All we could trace was a faint corridor in space, its trajectory back toward a region 9 degrees from where the WOW signal was recorded in 1977. Coincidence, most said. And yet the mind resists coincidence when patterns begin to repeat. If Atlas came from that corridor, it would mean it had been drifting across the Milky Way for eons, perhaps guided by chance, perhaps by purpose. What kind of civilization could send a fragment across such distances, or what kind of cosmic accident could forge an object so precise that it looks like intention? Even if purely natural, its existence was still a kind of message. A proof that materials can survive longer than worlds, that memory can exist without mind. Imagine a piece of a dead star system still glimmering under another sun, whispering through the void in frequencies we barely understand. It doesn't need to be a ship to carry meaning. Its meaning is survival itself. One astronomer wrote in his notes, "Maybe 3 Atlas isn't a messenger. Maybe it's a fossil, the memory of an attempt that outlasted its makers." There is something humbling in that thought. In a universe that forgets everything, planets, species, even stars here, drifts a small, silent remnant that remembers. Its metals forged in another dawn, its surface burned by alien suns, its story written in isotopes rather than language. Perhaps that is the true secret of Atlas, not that it hides technology, but that it is technology the kind that nature and time create together. As it continues outward, now past Mars, into the cold, where sunlight fades and silence deepens again, it carries no answers. Only the quiet endurance of matter older than Earth, older than memory, proof that in the vast machinery of the cosmos, survival itself can be an act of design. It began as a faint coincidence, the kind that scientists are trained to ignore. But in cosmic investigation, sometimes a coincidence is all we have. When the first orbital projections of 3I's Atlas were compared against deep space radio archives, a subtle pattern appeared. Its inbound trajectory, the narrow corridor of interstellar space it had crossed before entering the solar system, pointed to a region strikingly close to the coordinates of the WOW signal. The mysterious narrowband radio burst recorded in 1977 at the Big Ear Observatory in Ohio. The alignment was not exact, but close enough to raise eyebrows, a difference of only 9 degrees. For decades, the WOW signal has remained one of astronomy's great enigmas, a sharp, singular spike at 1420 MHz, lasting just 72 seconds, never to repeat. It was the frequency of neutral hydrogen, the most universal element in the cosmos, and for that reason long considered the logical channel for any civilization wishing to announce its presence. Now nearly half a century later, another anomaly had appeared, one also centered near hydrogen frequencies, also transient, also unexplained. Atlas's post-perihelion radio emissions detected at 1.6 as 65 and 1. 667 GHz fell within the same electromagnetic family. Hydrogen and hydroxyl, the two ends of the cosmic water molecule H2O. It could be coincidence. But coincidences this elegant tend to make scientists uneasy. Dr. Avi Loeb ran the numbers. He calculated the probability that two independent phenomena separated by nearly 50 years would align both spatially and spectrally by chance. The odds were small, 1 in 10,000. Not impossible, but enough to warrant a pause. What made the link even more intriguing was the behavioural symmetry. Both events were sudden, short-lived and non-repeating. Both occurred at frequencies tied to the chemistry of life. And both came from directions with no known pulsars, quasars or repeating astrophysical sources. For the first time, serious researchers began to whisper the question they'd avoided for decades. What if the WOW Signal wasn't random noise, but a point of origin. Could 3A up Atlas be a fragment from the same region, or in the more daring versions from the same source that sent that long-lost transmission? Skeptics moved quickly to ground the discussion. Hydrogen frequencies are common throughout the galaxy, they argued. Any alignment could be coincidence, any signal a product of reflection, any mystery an illusion of human pattern seeking. And yet even skeptics could not ignore the alignment. When the Harvard-Smithsonian Center for Astrophysics reprocessed the old 1977 data with modern algorithms' faint sidebands, appeared fluctuations around the main hydrogen line matching the offset frequencies of hydroxyl. It was not proof, but it was enough to reopen the conversation. Could the two phenomena, separated by time but connected by spectrum, represent two halves of a single message, hydrogen plus hydroxyl, the formula for water, the universal solvent of life? If intentional, it was elegant beyond words. If natural, it was coincidence raised to poetry. The thought that perhaps we were not looking at a comet but at a messenger, or at least a relic from the same cosmic neighbourhood that once whispered "wow" across the void unsettled even the most disciplined minds. In closed meetings, researchers debated whether to even mention the correlation publicly. To connect Atlas with the wow signal was to step into the realm of speculation. But the numbers were persuasive, and curiosity has always been stronger than caution. Some proposed an intermediate theory resonant coincidence. Maybe both phenomena stem from natural hydrogen resonance in dense interstellar clouds, a kind of cosmic echo chamber that amplifies specific frequencies. Atlas, passing through that region eons ago, could have inherited isotopic patterns from it, explaining both its radio signature and its unusual chemistry. In that sense, it was not the sender of a message, but a souvenir of the place where the message originated. Others leaned further into metaphor. If the wow signal was a hello, perhaps Atlas was the footprint, the physical trace of a civilization that once called out, now reduced to silence and motion. No one could prove it, of course, but the symmetry between hydrogen's voice and Atlas's glow haunted everyone who studied it. In an essay published quietly in Astrophysical Letters, Loeb concluded, "Whether the similarity is physical or symbolic, it demands humility. Two events separated by half a century may together represent a single phenomenon we do not yet have the language to describe, and perhaps that is the lesson hidden beneath the data. The universe rarely repeats itself, but when it does, it may be whispering a pattern we have yet to recognize. The trajectory of Atlas and the direction of the wow signal cross only briefly in the map of the galaxy, a fleeting overlap in the great dance of matter and meaning. But to those who have traced both paths, it feels less like coincidence and more like conversation. Maybe the signal and the object share nothing at all but timing and chemistry. Or maybe across billions of years and light years they are two syllables of the same cosmic sentence, one written in radio, the other in light. And as always, the universe leaves us to wonder whether it was speaking to us, or simply reminding us to listen. When the last datasets were compiled and the final orbit confirmed 3I, Atlas was already fading from sight, a quiet ember retreating into the cold beyond Mars. Its story, however, refused to fade. Across observatories and institutions from Cambridge to Tokyo, one conclusion began to crystallize: whatever 3I Atlas was, it did not fit the model. Not for a comet, not for an asteroid, not for any known fragment of cosmic debris. It was an anomaly, a reminder that the universe still holds more exceptions than rules. In the sterile clarity of equations, we like to think we understand how matter behaves, how light scatters, how dust sublimates, how orbits bend. But then something arrives from the dark and behaves otherwise. It follows no pattern, obeys no comfort. It teaches us through its defiance that our laws are only temporary agreements with nature, valid until the next stranger passes by. Atlas has given science more questions than answers, a structure that breathes without tail, an acceleration without thrust, a signal without repetition, a colour without chemistry, and a silence that feels deliberate. Each of these puzzles may yet find an explanation in physics, in probability, or in our own tendency to see meaning where there is only complexity. But until we admit what we do not know, discovery remains impossible. The object's passage forced astronomers to confront an uncomfortable duality, that skepticism and imagination are not opposites but partners. To observe a mystery without declaring it miraculous, to speculate without surrendering reason, that is the true discipline of science. We can calculate trajectories with perfection, but curiosity still demands humility. Every time we claim certainty, the cosmos offers correction. When asked about the meaning of 3I, Atlas, Avi Loeb summarized it with disarming simplicity: either it is a new kind of natural body, or we have witnessed the remains of something once made. In both cases, our understanding of the universe must expand. That statement captured the spirit of this moment, a rare intersection of data and wonder. For if Atlas is natural, then nature has learned to imitate purpose. If it is not, then purpose has endured long enough to become nature. Either way, the distinction begins to blur. Throughout history, every leap in science began not with confidence, but with confusion. The heliocentric model began as heresy. Quantum mechanics began as contradiction. Even the theory of relativity was born from a failure to explain a small, stubborn anomaly. Perhaps Atlas is another such anomaly, a quiet herald of physics yet to be written. The lesson it leaves us is not to believe in aliens or miracles, but to believe in the unknown. To treat each anomaly not as threat, but as invitation. To let data speak before dogma translates it. Because what if the next visitor arrives, and we are too certain to notice what it means? Transparency, open data, and cross-disciplinary dialogue are not luxuries. They are necessities for a universe that refuses to fit our models. When information is withheld, even for caution, speculation fills the void. When science closes its doors, mystery becomes myth. And myths once born are hard to silence. That is why the true legacy of 3I Atlas may not lie in what it was, but in what it taught us about ourselves, our need for control, our fear of error, and our fragile balance between wonder and proof. If the cosmos could speak, perhaps it would tell us, do not rush to define me. Watch longer, listen better, doubt more gently. Maybe the object was nothing more than a comet made strange by coincidence and angle. Or maybe it was something greater, a fragment of memory, a shard of intention, a message written not in words but in endurance. Whatever it was, it came, it glowed, and it left quietly rewriting our sense of what might drift between the stars. And in its wake, it leaves a single commandment for every scientist, every dreamer, every listener who looks into the dark: stay curious, stay honest, and never mistake silence for absence.